Hi everyone, I hope you've been doing amazing. Thank you for tuning in into another dbt video. And this time we're going to see how we can put materialization to practice in dbt. In my last video, I've gone in depth to explain all the 4 different types of materialization that exist in dbt, and this time we are going to see them in practice. If you're new here, then I'm Radhika and this is my YouTube channel Datazard. If you are liking this series and are finding this videos helpful, then please do subscribe to my channel, hit the like button and show your love in the comments. And now without further ado, let's get started. Now let us jump into our dbt project, and in here I will first go to dbt_project.yaml file. And here we have already seen 2 types of materializations till now, view and a table. What I have done now is I have added a config block at the top of every model, and I've added this config which says get the database name depending on what is the environment, and I've done this for all of them. Now if I show you this in our Snowflake, then you can see that I have 3 different databases. HR Analytics, this is the one that we were originally using, then Dev HR Analytics and Prod HR Analytics. So this is where I'm syncing the data. So from my AWS account, I'm syncing the data over here, and here I'm also creating these seed files. Then in my dev environment, when I did the dbt run after adding this config block at the top of every model, because I was in the dev environment, my bronze layer, silver layer and gold layer all were built in the Dev HR Analytics database. This is because the database name is picked up via this config. Now, as I was mentioning that if we go into dbt_project.yaml file, we said for bronze model or bronze layer that materialization should be view. So you can see that in our bronze schema, we have bronze HR data and bronze config threshold. They are both created as views. Then when we go into our silver layer, our materialization was table. The config says materialized as table, schema was silver. So if we go into the Dev HR Analytics, our silver schema, we have 3 tables created. We don't see any views like there were in the bronze model. And lastly, if we go into the gold layer, then the materialization is again a table. So again, if we go to the gold schema, we have 2 tables created. So you see that using this materialized config in the dbt_project.yaml, we are able to change the configuration. We can do similar things in these config blocks as well. We can just write materialized over here and give whatever materialization we want. And we can also give in dbt_project.yaml. It is up to you. The best practice is if it is a global config, like for every bronze model, for every silver model, etc., then you should place this in dbt_project.yaml file. But if it is specific to a particular model, then that config can go into the model file. Now let us understand the third type of materialization, which is incremental. Now, like I explained in my previous video regarding incremental materialization, that every time we're going to do dbt run to build these models, it's going to build the entire data set, like from the source, however many rows were there, they're going to be brought into our bronze, silver and gold layers. So even if there are only new rows getting added, let's say in our source, we're going to rebuild the entire data set. So let's say if there were 50k rows, then again 50k rows will be added. If next day there are 50k rows plus 5 extra rows, for just those 5 rows, we are going to be rebuilding and re-pushing those 50,000 plus those 5 rows into our warehouse. So we are trying to rebuild this large data set. Suppose there are millions of rows. So instead of rebuilding the full data set, the best strategy is to do this incrementally. So we are only going to bring in the updates or the added rows into the data warehouse. We are not going to rebuild the data from scratch. So this is exactly what we are going to do in the incremental materialization over here. Now I want to call out that this data set is not having those millions of rows, But because I just want to show you the functionality of how an incremental model can be created, that's why I'm doing this over here. But I want to say that for this particular data set, we don't have to worry about creating these models as incremental models. If this data set was, let's say, employee attendance being added as one of the sources, so then maybe we could have changed that particular model into an incremental model, because attendance is just adding records. None of the records would get updated. So that would have been a better use case for doing an incremental materialization. But for now, let's just stick to what we have. And here we are going to build this particular bronze HR data into incremental materialized rather than being a view. Now there are three important things that we have to add to our model to make dbt understand that, hey, this is an incremental model, not a usual table, because ultimately a table will get created, but that table will be incremental table for incremental materialization and a regular table for a table materialization. So the three key things are, first, we have to change the config. Second, we have to let dbt know that what is that filter via which you can see that whether this is a new row added or not. And the third thing is, we have to make dbt understand that if this is the first run, then we want the table to be created, or we want the data to be synced into data warehouse as a usual table, like the full sync should happen. But from the next runs or the subsequent runs, we only want the new rows to sync into the data warehouse. So these are the three key things that need to be added. So now I'm going to start modifying this bronze HR data, and I will be adding those three key things to convert this model into an incremental model. Now currently this model, if we go to our Snowflake, it is a view, bronze HR data in bronze schema. But we want to convert it into a table, and that to incremental table. So the first thing that we need to do is we need to change the config. So materialized should be equal to incremental. That's what we are going to add. This is the first step or first change. The second one is we need to add a filter via which dbt can know that these are the records that need to be fetched. For us, we are going to use this created at. If this created at is greater than the maximum created at that is present in our data warehouse, then we want those rows to be added into our table, otherwise ignore them. So what we can do is we can just say where to date created at, because I'm not sure if created at is currently a date or not, so that's why I'm just making that conversion, is greater than, and then here I can add select max to date created at from this. I'll explain you what this is. So what we are doing is we are adding a condition that when the created at is greater than the max created at from this, this means dbt knows that when you write this, it's going to replace this with the name of the model. So this is going to be whatever your database is, then your schema name, then your table name. I'll show this to you in the compiled code. But this is exactly what we are doing. We're just fetching those rows which have created date which is greater than what we have existing in our data warehouse. But this will not do the job, because for the first time we still have to fetch all the rows, and this will not do a good job over there. So what we need to do is we need to add that particular incremental logic, that incremental block, which tells dbt that if this is the first time you're doing this or creating this particular model as incremental model, then you fetch all the rows. You ignore this where condition. However, for the subsequent runs, you put this where clause in the model itself so that we fetch only new rows. Let me show you what I mean. So here I'm going to use a macro which is provided by dbt in if condition. So if you see here, what I'm doing is I'm saying if is incremental. This is a dbt macro, and what this does is it first checks whether this particular model exists in the data warehouse or not. If it does, then it will return true. And if it returns true, then this where condition gets added, because we are saying if true, then add this. So that's how we are telling dbt that in subsequent runs, we want this where clause. Only fetch those rows which are not existing in our data warehouse. However, If this is the first time you're doing it, then is incremental will return as false because it will not be able to find the model in our data warehouse. And that's when this condition will not be added and your full model will be created, like all the rows will be fetched from your source into your model. So this is how we are automatically telling dbt that if this is the first time, you have to do this. If it is subsequent runs, then action this. So in this way, we are automating the entire process. We don't have to intervene in between. So you see here we have three things. First is we changed the materialization, so added this config. Then we added the filter condition. Then we added this if is incremental block to tell dbt that it has to do different things depending on whether this model exists in the data warehouse or not. Now let's just try to run this. So I'm going to do dbt run select, and I'm going to select this model, so bronze HR data. And now you see that it says SQL, create SQL incremental model, and here. So let's go to our Snowflake. Here you were earlier able to see it as a view. Now let me just refresh it and this view will be gone and a table gets created. And this is what we were referring to as incremental table. It will still look like a table, but it will be built incrementally. Now if I see the max created at date, in this particular table right now, it is 9/12/2025. Now what I'm going to do is I want to show you that it only adds one record. So I'm going to insert this particular record where I'm adding this particular employee 100120 with a created at date of 1st April 2026. So in this way, this is the new record that has been added. Let me just insert this. And now before I do dbt run, let me show you the compiled code as well for this one. So let's go to target, compiled, model, bronze, and then bronze HR data. And if you see here, all we have is from HR analytics staging HR data. You don't see that where clause condition right now because that was the first run. dbt knew that that model, like this particular bronze HR data model, does not exist as an incremental model in data warehouse. So it did not add that condition. But let's rerun this and then we will again go back to our compiled code and see what happens there. So currently the model failed. Okay. I misplaced those brackets. Let's run it again. I believe the issue is the date format, like the format in which the dates were coming. So I've added the format that I want in both the places. And now I'm running this. So I had to have the same format on both the ends. That's how the comparison was happening. So now if you see, if we are going to our compiled code, earlier we did not have any where condition when the model was first built as incremental model. But if I go over here now, this is the compiled code again, and you can see that this where condition has been added. And if you see this has been replaced by dbt with whatever our model was. So that is dev HR analytics, bronze and bronze HR data. From here it is finding out what is the max created at date, and then it is comparing with the date that's coming from here. And if the date is that is coming from here, that is staging is greater than whatever max it has in the bronze one, then it is adding those records because genuinely those are the records that were newly added. So this is exactly what is happening. And now if I check for the max created at date in dev HR analytics, earlier it was in 2025 created at. Let's add the format as well. And now you can see that the max date is 2026. So it definitely got added into our model. And how do we know that only one row was added? So because we have this particular filter in the compiled code, if I go to our compiled code, we have this filter. This filter will only fetch one row. So how do we know that only one row got added and not the 1471 rows created all together? That's because we have this in the compiled code, we have this where clause. It says where the created date is greater than the max created date for this bronze HR data. So that's how it's just picking one record and adding one record. So this is pretty much how an incremental model gets created. Now there are lots of nuances when it comes to incremental model. It's not pretty straightforward. There are a lot more complexities involved. So I will be dedicating a full video on incremental models that I will release in the coming weeks. So hopefully that will give you an idea of the complexities and how to set up this incremental model. But I wanted to give you a foundation to think about these things because these are really important when it comes to real world use cases. Now enough of this model, let's jump into our ephemeral model. To understand ephemeral models, let's go to our gold layer, and we have two models in the gold layer. First is gold employee features and the other one is gold attrition scoring. Now in both of these models, we have this config and config pivoted. Now what we can do is, instead of using this as CTE, I can create these as ephemeral models because it is kind of the same logic that we are applying over here. Now this may not again be the best use case of making this as an ephemeral model, but as I have to show you how to create these models, so I'm just thinking of this particular use case. Feel free to use any other use case that you like. So what I'm going to do is, I'm going to create a model and I'm going to do that in the gold layer, and let's create a new file and I'm going to call this gold config thresholds ephemeral.sql. So this is the file that we have created. Again, we have to add the config block. So I'm just going to copy it from here so that it is quick and paste it here. And we can add materialized. So materialized equal to ephemeral here. So we are creating this model as ephemeral model. And now I'm just going to copy this part from here and let's add it in this model because this is exactly what we have to create. And I'll get some data from here as well, some code from here as well. So let's get this and I'm going to adjust the formatting. This looks good. And now we can just say select star from config pivoted because that's what our final CTE is. So we have got this logic. We have created this as an ephemeral model, which means this model is not going to sync into our database because it already exists. We don't want this pivoted data, etc. to go into our database. So what we are now going to do is, let's go to our features table, and in here, instead of this logic, I'm just going to say config and replace this logic with select star from our ref keyword. So curly braces, then ref keyword and our model name. So the model is gold config threshold ephemeral. And I'm just going to say this as config pivoted because that's what I have called the tables here. So I don't want to change the names and everything. Similarly, I'm going to do the same thing in the other table as well. That is the attrition scoring table. So let me actually just replace this logic and I'm just removing this part. So with config pivoted as this, let's save it. Now there is one change that I have done in the config thresholds ephemeral. Instead of calling this as config pivoted, I have called it as config pivot, just because I want to avoid any name conflict between these tables and the CTs, etc. and confuse you. So I have changed the name over there. It is up to you if you want to change it or not. The question that would come into your mind is, in these tables, we are referencing the ephemeral model same as we were referencing the other models which were of other materialization like incremental, table or view. So what's the difference here? The difference is, for view, table and incremental models, this ref was being translated into the database name, schema name and the table name because the data existed in our data warehouse. However, for this ephemeral model, the data is not available in the data warehouse. This model never goes to a data warehouse. So what dbt does is, it will replace this with the exact code from the ephemeral model. So that CTE will be called out over here directly. We will see in the compiled code what is exactly the output of this, but let's just first run it. Now before running, I want to delete our gold layer from dev HR data so that we know that the ephemeral model that we are creating is getting synced into drop table this and drop table gold employee features. Let's drop both of them. And now if you see, our gold schema does not contain anything. Now I'm going to run it. So let's do dbt run -- select. I'm first going to run gold employee features. And you can see that it has passed. Now I want to first show you the data. So let's go into our Snowflake, refresh it, and you should be able to see that the table has been created. So the model has been created. Let's just double check it has contents as well. So let's call this table, select star from, it should have 1470 rows. Yes, we can see that. Now let me show you the compiled code to explain you what I was telling earlier. So I'm going into target compiled models and the gold one, and I'll go into the gold employee features because that's what we have run right now. And if you see here, we have got this CTE dbt _ dbt _ CTE _ gold config threshold ephemeral. This we did not write in our gold employee features table model. So it is not existing in our model. Let me just open the model as well. So I'll keep this open. And let's open this too. So if you see here, we have just referenced this ephemeral model. So what dbt will do is, it will go into our model. This was our model. It will replace our code where we were calling the ephemeral model with the exact contents of CTE, and it is going to wrap it inside this with clause. So this is what it has done over here, and then the rest of the contents, they remain same. So we have got base, we have got average matrix, config pivoted, final, everything is there, and we are referencing the dbt CTE gold config thresholds ephemeral, what dbt has placed over here, the code that dbt picked up from our ephemeral model and placed it over here. It is referencing that here instead of the ref keyword. So if you see the ref from above, like this particular base CTE, it gets translated to the database name, schema name, and the table name. But our ref for ephemeral model got translated into the CTE name, and the CTE has already been added by dbt for us into our own model. So this is exactly what happens in a ephemeral model. We can do the same thing for the gold attrition scoring as well. So let's do that. And you can see that both the models, they have been created successfully. So it might be a little confusing as to what's happening with ephemeral, but to sum it up, because our ephemeral models, they don't go into our data warehouse, so there is no way for us to reference them using database name, schema name, and table name, which exactly what ref used to do. So for ephemeral models, when you use ref with ephemeral models, what it will do is dbt will get the code of your ephemeral model, write it as a CTE in the model that you are referencing it, which is exactly what it has done over here, and it will just build your model the way it usually does. I hope this is clear. If you have any questions, as always, put them in the comments below. That's it for this particular video. I have shown you practically the different materializations, which is view, table, incremental, and ephemeral. How do these work in dbt? How do you configure them in dbt? And how these are reflected back in your Snowflake. Thank you for watching. I will see you in my next one.